Andrea, what are you doing? Okay, well, this is kind of a big lesson, so I'm going to do my best to get through it all. Okay, so reciprocals. We know what a reciprocal is. Easy peasy, right? If I give you the number 2, what's the reciprocal of it? How about 1/2? It's the flip, right? We're flipping it over its denominator. If I give you the number 2/3, what's the reciprocal of that? 3/2. So it doesn't change the sign, it just changes the numerator and denominator. They switch places. Make sense? Okay, so that's a reciprocal function. What if I gave you x? What's the reciprocal of x? 1/x. We're going to graph that today. Okay, so, and then I'm going to go one more. What is x plus 2? What's the reciprocal of that? Okay, so I just want to point out that it's 1/. This whole thing goes on the denominator, so it'd be 1/x plus 2. So that 2 doesn't stay on top or anything like that. Like that x plus 2 is one thing. We are also going to graph this. Okay? And then we're going to do some with parabolas as well. Because that's what all the cool kids are doing. They're not wearing snow pants, but they're graphing functions. All right, a reciprocal function. We are going to switch the numerator and denominator. Now, in reciprocal functions, in this case, all numerators, I'm supposed to say numerators, in reciprocal functions will be 1. So what we're going to graph is we're going to graph things like this and like this. We're going to graph the original function and its reciprocal. So if we're looking at a reciprocal function, its numerator should be 1. When we get to grade 12, we're going to put x's on both the top and the bottom. But in grade 11, we're just going to put x's on the bottom. Okay? We'll start small. Okay, an asymptote. An asymptote is an invisible I want to say horizontal or vertical line. That the function never crosses or touches. So they're kind of like invisible boundaries. So we can get close to them, we can get really, really close to them, but we can't touch them. Okay, this is exciting. I'm trying to crunch away from the microphone. Okay, an invariant point. This point is on the parent graph or the original graph, and it doesn't change on the reciprocal graph. Does that make sense? So the point's the same on the parent graph as it is on the reciprocal graph. They're really specific points, and they only happen in 2 places. But we'll get to that later. Invariant point. Point on the parent graph that stays the same on the reciprocal graph. Okay, exciting stuff. You guys good? All right, we're going to baby step through this whole thing. Yeah, baby steps through the whole thing. Okay, so this is pretty straightforward. A reciprocal function is a function in the form of f of x is equal to 1 over some other function g of x. And that might make you feel uncomfortable because I got to tell you, grade 10 function notation probably wasn't our strongest suit. Like, I think people have a lot of hard times with the notation of it. All this means is that y equals 1 over some function. This is a new function. That's all. That's all it's saying. It's nothing special or crazy. Now, where g of x, so that function on the bottom, is a polynomial. What does polynomial mean? Many terms, right? Could be a monomial, could be a binomial, could be a trinomial. Poly just means many or any number of terms. And the domain of the reciprocal function consists of all value of x for which g of x cannot equal 0. So that's a lot of math speak, but you guys know this. What can my denominator not be? 0, right? Because anything divided by 0 is going to give us an error on our calculator. We'll be sucked into a black hole. So really, this is just math speak for the domain is the same except for when this is equal to 0. So when would this be equal to 0? When would that denominator be equal to 0? Go back to chapter 6. What would I find here? Your NPVs, right? Your non-permissible values. So what's my NPV for this one? -3. So we would say that x cannot be equal to -3. Ladies and gentlemen, you found the equation of your asymptote. It's that easy because you've done MPVs. You know why we do MPVs. Now we're just going to make this visual on a graph. So let's write a little note here. NPV equals vertical asymptote. And we're going to talk about how we draw asymptotes and stuff like that. I will tell you that Desmos, just FYI, won't put an asymptote on there. The graph will show asymptotic behavior, but it won't show the actual asymptote. Same with my graphing calculator. So you got to be smarter than your graphing calculator. Okay, so here's your first graph. I'm not even asking you, well, we're going to talk about the graph. Do you guys know what, let's do this graph first, y equals x. How do you feel about that? Let's do a table of values for that. -1, let's go -2, -1, 0, 1, and 2. Okay, so if this is my function, and I've picked my x values, what are my y values? Y equals x. So if x is -2, what's y? Also -2. So -2, -1, 0, 1, 2. What kind of line does that result in? It's not going to be a vertical line. It's actually going to be a diagonal line. But I think you meant linear. I think that's what you were talking about. It's going to be a straight line. So if we were to graph that, that would be like 0, 0, 1, 1, 2, 2, -1, -2, -2. So you'd end up getting a line that looks like this. Okay, so that would be that line. That's just, so this would be the parent. That would be the parent function. Okay, and I say this all the time, we are going to, table of values will never lead you wrong. So if you ever get lost in all of this, we're going to do the reciprocal. So we are going to do the reciprocal of this. So what is this one going to be? It's going to be y equals 1 over x, right? Because we're doing the reciprocal of that. So when I do my table of values, I'm going to pick same values just because that's who I am. All right, so if x is -2, what's y now? Nope. -1 over 2, right? We're just substituting the x value into the equation. So negative 1/2. That's exciting. Negative 1 is, what's the y value? Negative 1. Now it would be 1 over negative 1, which simplifies to just negative 1, right? If I put 0 in there, error. We're going to get an error at that point, right? Because we would get this for an answer, 1 with 0 on the bottom. We know that can't happen. This is an asymptote. So anytime we get that error, we get that like thing that we can't figure out, but that makes sense. What would be my NPV at this? X cannot equal 0, right? My NPV for this one is x cannot equal 0. At 0, when x is 0, I have an asymptote. That's pretty exciting. What about 1? 1. And what about 2? 1/2. Okay, so what you guys just found was an asymptote. So x equals 0. So when x is equal to 0, we have an asymptote. And I said that your NPV is going to equal your vertical asymptote. Everybody knows that vertical is up and down, right? Does everybody know that the equation of a vertical line starts with x? No? Did you know that? You did from grade 9. That's my Mondrain art on the back, and that was all x's and y lines. So if you have y equals 2, it's going to run this way. If you have x equals 2, it's going to run up and down. Okay? So you got to dig deep. You got to go back to grade 9. Okay, so we're going to put that asymptote on the graph. So x is equal to 0. That's right on the y-axis. Brendan, you having flashbacks?
Yeah, we didn't even have a grade 9. It was coded.
Sorry, guys. That's no fun.
Non-flashbacks.
Non-flashbacks. I will tell you that those are from the grade 12s year, so they would have been from the year before. They got to do art in my class. Okay, so there's my first asymptote. So I want to point out some features that I did on this asymptote. So I drew it in, but it is a dashed line. It's a dashed line. So my asymptotes have to be dashed lines on a graph because they don't exist. They're not part of the function. They're a boundary. They're like an invisible line that you, like a force field, like you can get really, really close to it, but you can't actually touch it or cross it. So asymptotes actually don't exist. So we have to indicate them with dashed lines. Okay. There is another asymptote on here, and it is your horizontal asymptote. Where do you think that's located? If you're just looking at that graph. Right, so on the x-axis, y equals 0, those are the same places. So we have another asymptote. Looks like the graph is coming really, really, really close to that x-axis, but never touches it. So I'm just going to put my dashed line in here. You guys can't really see that, but I promise you they're dashed lines. So with that, we know that there's no x or y intercepts. We know that we have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Again, your table of values is going to help you see all these things a little bit better. And then we're going to get to the point where we're going to go a little bit faster and do some helping tricks and tips, and we'll slow, baby steps, baby steps. Okay, let's flip the page. There's a lot of reading on this page. Okay, for the record, I shorten this down from what I give to my grade 12s. And then if you choose to do calculus elective with me, we'll throw these out the window and we'll do derivatives instead of this. It's super fun, and limits of functions. It's super fun. It's an elective, a half credit course. It's going to be a good time. Think about it for next year. Or if you're planning to go to an Ontario university, sometimes they will require you to have calculus, and that means you have to take the elective. So just Ontario schools, universities are kind of picky about that, so just Little plug there for my calculus course. All right, so this is my helpful hints on how to graph a reciprocal function. Find and plot the y-intercept, if you have any, by evaluating f of 0. I think we all know how to find the y-intercept by now, but really we just set x equal to 0 and solve for y. So you're going to substitute a 0 in everywhere you see x. That's exciting. You're going to sketch, so straight lines. A ruler is handy. Sketch the corresponding asymptotes by solving the equation of the denominator to find the zeros of the denominator. So in other words, find your MPVs. Those are going to be your vertical asymptotes. Okay? So y-intercept, vertical asymptotes. Now, to find your horizontal asymptote, I wanted to show you that there's 3 options, but I'm going to tell you right now that in grade 11, this is the only one. Do you guys know what I mean by degree? Do you guys know what I mean by degree of a polynomial? Good try, good try. Degrees and angles usually go together. So a degree of a polynomial is the highest exponent. So a polynomial with a degree of 4 would be something that has, it could have a cube in it, it could have a square in it, but its highest exponent is 4. So when we look at my equation 1 over x plus 2, what's the degree of the x on the numerator? Do I have an x? So what is it here? 0. What is it on the bottom? What's the exponent? So degrees have to do with exponents. What's the exponent, the highest exponent in the denominator? 1. But the top was 0. So the degree of p of x, so p of x being your top, is less than the degree of g of x, then y equals 0 is going to be your horizontal asymptote. Now in grade 12, like I said, we're going to put x's on top and bottom, so then you have to know these 3 rules. Grade 11, right now, you are stuck with option A only. Okay, so you just have to memorize that one. Okay, so 4, use a table of values to graph a few key points to create the shape of the graph, and then use smooth curves to complete the graph between and beyond the vertical asymptotes. Easy peasy, right? Easy. You guys are good. You guys are good. Okay, flipping the page. Flipping the page. We're going to do our first one. Okay, so we have this one, and we have a parabola to do. Okay, big deep breaths. We're going to go through each piece together. So it says, graph the function and the reciprocal of the function. So you're going to put 2 graphs on this. You're going to graph the parent, and what does the reciprocal function look like? Okay. And I think by opposite, you mean that. Okay. So on this graph, when it says those words, and that's the way I'm going to give it to you, is graph the function and the reciprocal of the function. So I'm asking you to graph the parent function and its reciprocal. Okay? So I'm just going to label that one as the parent. Just so you guys know what I'm talking about, so it's that original function. Do you want to graph that straight line first? Easy peasy. How do you want to do it? Do you want to do intercept and slope, or do you want to make a table of values? Intercept and slope. Okay, so let's get started. And we are going to, so I have a y-intercept at -9. So that's going to kind of gauge my, so this has 1, 2, 3, 4, 5. So I'm going to guess that's -2, -4, -6, -8, -10, 2, 6, 8, 10. Okay, what are we going to do with our x's? Are they going up by 2s or are they going up by 1s? 2s? You'd like to keep it the same? You guys are creatures of habit. I like it. Again, if you choose a different scale, your graph may look a little bit different, but chances are it's exactly correct. All right, I'm going to graph it in green. All right, so I'm going to cross at 9. So there's my y-intercept. And what's my slope? 3 over 1. So that means I'm going up 3, 1 to the right. So then I will be at 5 and 1 to the right. So I'm right here. And then I'm going to be at 2. I'm going to be here. I'm going to be at 1. I'm going to be here. I'm just going to talk myself through this. I hope you guys don't mind. Did I miss one? Oh. It should be 6. And I'm not using an erasable pen. What am I going to do? What am I going to do? I love it. Thanks. Good strategies. Just cry. You'll be fine. Okay, did your graph look better than mine? Nice. Okay, look at that. It's like it never happened. Except I'm recording it and it did happen. Okay, -9, and I'm going to add 3 to it, so you're telling me I should be at 6, but I got to go 1 to the right. And then I should be at 3 and 1 to the right. Does that look better? Oh, counting is hard. And then I'm going to be at 0 and 1 to the right. Oh, that makes sense. Because what's the y-intercept, or the x-intercept? +3. Okay, I'm going to keep going. 1 and 3. 1. You guys are like, Skyline, this is a lot of points. You know, I just feel like I want to connect them all. Okay, so this is one graph that you have to graph. So I'm going to connect them with a nice straight line. What else do I have to do if I'm getting marks for this? Label the graph for sure. So this one is the f of x graph. And I need to do one more thing. I think you said it for me. Label 2 points. So I'm going to do 0 and -9. And I'm going to do 3 and 0. Okay, so graph that function. Parent function has been graphed. Okay, you guys ready? Now we're going to graph the reciprocal. So now we're graphing this one. So step 1 said find the y-intercept and graph it. So step 1, y-intercept. So that means x is going to be 0, right? So g of 0 is equal to 1 over 3 times 0 minus 9. So it should be 1 over -9. All right. So that's a really close, really close to 0, right? If we were to graph that point. Yeah, 1/9. Really close to 0. Okay, there. I should probably use not blue. I should probably use red. All right. So then step 2 was to find your NPVs and make those vertical asymptotes. Okay, so NPVs, what are my NPVs? Come on, guys. So we have 3x minus 9 equals 0. So we're going to have 3x equals 9, divide by 3, divide by 3. X is equal to 3. This is the equation of your vertical asymptote. Okay, and remember that it is a dashed line. I'm just taking the opportunity to write all this stuff down so that you guys have full and complete notes that you can look back at. I don't expect you to write down everything, and if you're a good rememberer, then don't feel like you've got to write that down. Okay, so I'm getting my handy dandy ruler out again. And I'm going to go to x is equal to +3, which is right there. And I am going to draw in a dashed line. It is dashed because it's not part of this function. It's not part of this g of x function. It is simply a boundary. Okay, good job. All right. What do I do next? I think I do my vertical asymptote next. And that's the one we just have to remember. Or horizontal, sorry. You're just going to memorize that it's y equals 0. I just want to say that that's the case for reciprocal functions. It's not the case for rational functions that we're going to have x's top and bottom. So I'm going to put that asymptote on as well. And again, if it's an asymptote, it's a dashed line. Okay, I'm going back to my graph. I hope that nobody's getting nauseous watching. And y equals 0 is right here, is my x-axis. That's exciting. And again, has to be a dashed line. And if you can't see it, like if you're using like a black pen or a pencil on a thick lined graph, just extend it out a little bit so that I know that it's there. I'm going to be looking for asymptotic behavior, but I still like to see the asymptotes. Okay, and I don't know what we're on, step 4. Step 4, it says do a table of values of key points. Table of values for key points. Okay, when I'm talking key points, I want left, right of horizontal, no, vertical asymptote. You don't have to do a lot, you just have to do enough to see the shape. Okay? And we need to label at least 2 points on the graph anyway, so we got to do some work. All right, so table of values, x and y. All right, so my vertical asymptote occurs at 3, so I want to pick points to the left of 3 and to the right of 3. Okay, so let's do the left-hand side first. Going to give you a nice hint. You went up by 2, so pick numbers that involve 2s. So maybe we'll do, and we're going left first, so I'm going to do -4, -2. Ooh, we did 0 already. That was with -1/9. That's exciting. I did that one already. And I'm going to pick a +2. Because at 3, we have our vertical asymptote. I'm just going to write that into my table, kind of lock it in place. Okay, so let's do some calculations, ladies and gentlemen. We are going to substitute that -4 into the equation. So I'm just going to pop this off for a second. So g at -4 is equal to 1/3 times -4 minus 9. -12 minus 9. So 1/-21. Let me put this back here. 1/-21. Whew, that's a small decimal. Okay, let's put 2 in there. Can we do this one in our head? Can we go back up and just put -2 in there? So I have a -6 minus 9. -15, but remember we're in the reciprocal graph, so it's 1/-15. Okay, let's put a +2 in there this time. +6 minus 9. Okay, so what do you notice about all these values? They're tiny. What else do we notice about them? They're all negative, right? They're all negative. The reason why is because they all live under that horizontal asymptote. So they live in this quadrant here. Okay, so let's try to do them. So -4 is, I don't know, I don't think that looks any different than my 1/9, but 2 and -1/15. So I'm getting closer and closer to this line. 0 and -1/9 we already did. 2 and a third would be like here. Okay, so now we're not done yet because we've only done the left-hand side of the vertical asymptote, but we're going to connect these points. So what I want you to know is that this shape is true for all of them. You're going to get as close as you can to the asymptote, but you have to go through your points. Got to hit all those points that we just labeled. Oh. You can't move away from the asymptote. It kind of sucks you in. You can't have your value go far away from it. So you're going to draw a line that's nice and curved and goes through your points, but it's got to point towards the asymptote to indicate that it's getting closer and closer and closer and closer to the asymptote. Okay, so you did the left-hand side. Good job, everybody. I'll give you a minute to graph. Oh yeah, we have a parabola to do. Okay, we're ready to do the right-hand side of the vertical asymptote. Okay, so if we were at 3, what are values greater than? 4, 6, 8, maybe. We'll try those ones. So again, we're going to substitute them into the reciprocal function. So we're going to have g of 4 equals 1 over 3 times 4 minus 9. What's that going to be? 12 minus 9. This time it's a positive 3. So on the table, it's going to be 1/3. If I put 6 in there, 6 times 3 is 18. 18 minus 9 is 9. So that's going to be a positive 1/9. 3 times 8, 24. 24 minus 9. What is it? 15. Are you sure? This time it's a positive. What do you notice about the values on this side? They're positive of the ones up there, right? Like, what do you anticipate 10 to be if you were to follow the pattern? 1 over 21, right? So it's like parabolas that there's some symmetry here because we're looking at distance away from the vertical asymptote. And as long as you keep that happening. All right, so we're now going to plot these. Right. Vertical asymptote. Okay, so we're going to plot these points. I'm going to slide this back up. So 4, I'm at 1/3. And 6, I'm really close. And 8, I'm even closer. So now, notice how I start my line way, way up here, because I need it to get close to that asymptote, and then come down through these points here. It should be a smooth curve, and your asymptote should not point away, or sorry, your function should not move away from the asymptote. Okay, so this is, you have just graphed your first reciprocal function. Yay, you! So you need both parts. You need the left and the right to make it a complete graph. So this one is your g of x function. And I labeled it as g of x over here, so I don't need to write this. I can just, as if I've stated it here. What else am I missing? 2 points, 2 points labeled, right? So I'm going to pick things that are far apart from each other. So I'm going to have 8 and 1/15. And then over here, I think I'm going to have -4 and -1/21. 20/21s. Okay, so ladies and gentlemen, you graphed your first reciprocal function. I'm very proud of you. Proud of you. There's a connection here, though, between the original graph and the reciprocal graph. How many x-intercepts do you have in the original graph? 1. How many vertical asymptotes do you have? 1. Where do they happen at? The exact same place. Isn't that exciting? Okay, that's an extra bonus piece. Okay, We got 27 minutes to do this one. So we're going to go a little bit faster, not much, but just a little bit, just so we can make sure you're getting all the pieces to it. All right, so it says graph the parent function and the reciprocal. Okay, here we go. What are the important points of a parabola? Vertex. What are the most important points on an absolute graph? X and Y intercepts. Same thing with your parabolas, right? So where's your vertex? It's in hidden vertex form, this one. So where's my vertex? You guys are like, I don't know, lady. I don't know. If I wrote it like this, would you be able to see it? Where's my vertex? 0 and -4. Those are the tricky ones because they look like we have to do math. What's my B value here, Darasimi? What? That's why I asked you, right? Because we had this conversation yesterday. What's my B value in this one? I don't have a single X, so my B value would be 0, right? So if you did the -b over 2a, you'd get the exact same answer. So how you choose to find your vertex is your business, not mine. You guys have a ton of ways to do it. But I knew that. Okay, x-intercepts, what do I do here? Nope, do the root of it. The root of it, because this is a difference of squares, right? So x plus 2, x minus 2, so my x-intercepts, one will be a -2, and one will be a +2. Just because if I multiply the 4's back together, I get 16. Okay, all right, let's graph those points. And literally, that's as much information that we need about a parabola. If you feel you need additional information, please feel free to get a table of values and graph additional information using your vertex as the midpoint in your table of values. Please feel free to do that. I think, ladies and gentlemen, I'm going to go up by 1s this time. Or you can go up by 2s if you want. No one will judge. Again, I'm the kid who has to label every point because I will screw it up. I even managed to screw it up when I label every point. All right, I'm going to put on my vertex, 0, -4. I get x-intercepts at 2 and 2. And then I'm just going to connect them with a smooth curve. How many points do I need to label in a vertex? Or in a vertex, in a function? Just 2. So I'm labeling my function because I'm putting 2 things on this graph. So I'm going to label my vertex, and I'm going to label my x-intercept. Okay, done and done. Good job, everybody. Now let's graph our reciprocal function. So step 1 was find the y-intercept. So when I'm finding the y-intercept, I'm substituting in 0. So I'm going to have g of 0 equals 1 over 0 squared minus 4. So that should be 1 over -4. All right. Good job, everybody. So it's going to be about there. Step 2 was non-permissible values. Non-permissible values equal your vertical asymptotes, right? So what are my non-permissible values in my denominator? Hint, hint. You've already done the work, right? You don't need to redo it because you did it up here to find the x-intercepts. So we know that we're going to have vertical asymptotes. One's going to happen at -2 and 1's going to happen at positive 2. Do you guys notice that I'm not using the cancel out sign? Like I'm not using the does not equal sign? And the reason why is because these are equations for the asymptotes. So we want them to equal that. They're just boundaries and you can't touch them. So I'm going to go back up to my graph. You guys are all going to be violently ill watching this graph. I'm going to get my handy dandy ruler. I'm going to throw on some vertical lines here at 2, negative 2, and at positive 2. And they're dashed because they don't belong to the function. They're just boundaries of the function. All right. The third step was, what's the memorizing one? Horizontal asymptote, y equals 0. Okay, I wrote some stuff down on the bottom of the page, but I'm going to just graph it while I'm here so I don't have to move that around. I'm putting my asymptote just slightly under, 1, because I didn't put my ruler close enough, and 2, it's nice because you can actually see it this time. It's a little trick. And you guys all have handy dandy rulers, right? Makes a math teacher cry a little on the inside. There is, if you guys ever get stuck, the bottom drawer at the back, labeled rulers, is flush with rulers. So you can go borrow one. You can use one if you want to. Okay, all I did there was say step 3 was horizontal asymptote, memorize y equals 0. Step 4 was a table of values of key points. I love my shorthand. It's terrible, and half the time you're going to go back and look at these notes and say, what does that mean? What does TOV mean? But table of values, we're not in an English class. We don't need to write these things down. Okay, so here's the thing though. We're going to find values left of this asymptote, in between the two asymptotes, and right of that asymptote. So you've got 3 sections of your graph now. So when I do my table of values, it might be handy to plunk in your information right away. So it reminds you that you have 1 section, 2 sections, 3 sections that you have to deal with. I don't know if that makes sense to you, but that helps me visualize what I have to do. Okay, so let's pick some points less than negative 2, to the left of negative 2. Negative 3, and maybe we'll throw in negative 4 for good value. Okay, so again, we're substituting them into the reciprocal function. So we're going to have g of negative 3 is equal to 1 over negative 3 squared minus 4. So 9 minus 4. 5. So in my table of values, this will be 1/5. And it's positive this time. Weird, but whatevs. So now I'm going to substitute in negative 4 here. So I'm going to have 16 minus 4. 16 minus 4, 12. So this will be 1 over 12. Okay, exciting stuff. Okay, now we're going to pick values in between. Hey, we already did 0. That's a negative 1/4. So maybe let's pick negative 1 and positive 1 in this one. So negative 1 squared minus 4. Negative 3. So that's going to be a negative 1/3. If I put a positive 1 there, what do you think it's going to be? Positive 1 squared minus 4. Same thing. So I'm doing some quick mental math. So if that's uncomfortable for you, again, go to a scrap piece of paper, substitute it into the original function. You guys don't, you guys are writing it down, learning it for the first time, and I'm expecting you to process mental math. That's a lot to ask. So if you're finding that this is just too much for you to do, make sure you use a scrap piece of paper. And so then we're going to pick values on the other side of 2. So I'm going to pick 3 and 4. 3 squared minus 4. 1/5. 4 squared minus 4. 1/12 again. So you guys should notice some things about your table. You should see some symmetry in it. You should see some beauty in it. You should also see positives are grouped together, negatives are grouped together, and positive are grouped together. You're never going to get, oh, I can't say that. In grade 12, we'll get it. But you won't get it in this one. You won't get positive and negatives in the same grouping. Does that make sense? This will change when I add more complex stuff into it. So just so you kind of have an idea of where to go. Okay, so let's graph this stuff. At -4, I'm at positive 1/12. At 3, I'm at 1/5, so maybe it's there. And again, that doesn't look like much, but that pattern still stays the same. You're going to have that line that approaches the asymptotes, approaches, curves, and then starts approaching the other asymptote. So I'm starting way up here. And I'm going to go through those 2 points. Ladies and gentlemen, if you put points on the graph, your graph better go through them. You get what I'm laying down here? Don't put a dot and then not go have your function go through it. Okay, so now I'm moving into the middle. So that's my 1/4 is already graphed, and so I have 2 around it. So this one's going to be here. And symmetry there. And these ones are going to look very similar to a very flat-topped, flat bottom. I'm not sure what we're going to call it. Flat-topped or flat-bottom parabola. And again, they have to be approaching those asymptotes. They have to get closer and closer and closer to those asymptotes. But you can't touch them and you can't cross them. And so now I'm going to just put on the 3, which is 1/5, and the 4, which is 1/12. And again, I'm going to draw my lines really, really close to the asymptotes. Put arrows on them. Sometimes we forget that. So my green graph, I'm going to label g of x. And again, because I defined what g of x is, I don't have to write it on the graph. And then the last thing I have to do is do 2 points. Ladies and gentlemen, you have to do 2 points over the entire green graph. You don't have to do 2 points for each section because you need 1, 2, 3 parts to make up the g of x function. Okay, so that all is one thing. So this is going to be -3 and 1/5. And I just like to pick points that are farther away from each other. So I'm going to pick 0 and -1/4, just so that all my coordinate pairs aren't squished together. And really, you can pick any points that you want. And that is it, ladies and gentlemen. Easy, right?